Hi guys, it's John the Quant here. This video is in the Bootcamp series. Now it is the second video of the series, but it belongs in the first week of the Bootcamp. If you haven't seen the first video yet, I highly recommend going back and watching it. It should be in the description below and it'll also pop up over here. Now this video is about structured query language, or SQL or SQL. Now this is a programming language that is designed for managing data in relational databases. And SQL is an important skill for all data professionals, especially in your early career. You're going to need SQL all the time. But it can be hard to practice at home because we rarely have relational databases available. Thus, we are going to use SQL-practice.com to help us learn some basic SQL. In the description below, there are links to some other online SQL courses. The SQL for Data Science course on Coursera, it's by UC Davis, is, in my opinion, excellent and well worth paying for. But in any of those linked courses, you're going to learn a lot more about how relational databases work and how to work with them. In this video, we're just going to cover a few basic commands in order to pull data out of a warehouse. And you need to know more than this. You need to learn more SQL on your own. When I started my first data science job, I really barely had an idea of how to work with SQL, and it really held me back. So while doing this bootcamp, you should be practicing SQL on your own. Now let's head over to the computer and learn some stuff. This is what SQL-practice.com looks like. For this video, we are working with the hospital database up here, hospital.db. If you click on this SQL database, it shows you all of the tables in the database. Let's go ahead and click play on patients. It pops up down here, and this shows you the entire table. You can see that this is what a relational database looks like. It's very much like the pandas data frame we saw in the first video, or like an Excel spreadsheet, which you may be familiar with. This patient ID column is very important. This column is the primary key. Remember those words, primary key, for this table. And every table should have a primary key column. And this column contains a unique identifier for each row of the table. For example, Donald Waterfield here is patient number 1. He is the only person who has patient ID number 1. And if any other table says patient ID equals 1, it is always referring to Donald Waterfield. So the primary key is the column that tells you which row in the table you're talking about. It's very important that it be unique. Let's take a quick look at the doctors table. But this time let's use SQL to do it. This is the most basic SQL query. Let's delete all of this. And we'll say select star from doctors. Here, select means we want it to return the following columns. This star is the wildcard, so it means all of the columns. From tells us what table to use, and doctors is the name of the table. Go ahead and run that. You can click run, or you can use Control-Enter. I prefer Control-Enter, so that's what I'm going to do. And here's the doctors table. What's the primary key here? Hopefully, you're saying it's this column, Dr. ID. James Russo is doctor number 4. And doctor number 4 is only ever James Russo. Let's use that same basic command to pull up the admissions table. So we're just going to change here, admissions. Again, select says, give me these columns. Star means all of the columns. From tells means this is the table we want, and admissions is the table name. Now I'm putting a semicolon on the end. That's kind of by habit. In many SQL workspaces, you can use semicolons to write multiple queries on the same page and still run them one by one. That can be really helpful, so I pretty much always just put a semicolon on the end. Run that. All right, here's the admissions table. What do you think the primary key is here? There isn't one. All right, there's no primary key in this table. There should be, but there isn't. So how do you think we can define a specific office visit without a primary key? Try to think of a solution. Here's mine. I think that in order to specify an admission, we would have to use a combination of patient ID, attending doctor ID, and the admission date. Hopefully each combination of those 3 fields is unique, but we would have to do some investigation to find out. And that's why it's important to always just have a primary key in every table, because we need a way to find specific observations, occurrences, and rows. So far, we've been pulling the full table every time, and that's been okay because our tables have been relatively small. See down here, the admissions table has 5,067 rows. And in a lot of real-world scenarios, a table might have millions or like tens of millions of rows, and pulling that whole table could take a while. So the first trick we're going to learn is how to limit the number of rows returned. The trick is the word limit. We're going to add limit 10 to the end of our query. When we run that, look, now it only returned 10 rows. This is a great way to investigate a table, or if you don't remember what the data in the table looks like, you can just pull a few rows and then have a look at it. It's very simple and very effective. But what if we only care about certain columns? Say, if we just want to see the patient and which days they were admitted in the hospital. Remember we said earlier that this star wildcard means all columns. Well, we can replace that star with just the names of the columns that we want. So let's replace it with patient ID, you gotta spell it right, patient ID, comma, admission date, comma, and what's the last one? Discharge date. So now when we run that, it returns only the columns listed, and because we kept limit on the end, it only returned 10 rows. Now what if we cared only about a specific patient? If we only want to pull rows that are, say, for patient number 1, we'll add a different clause. I'm going to delete the limit there, and I'm going to move admissions to the next line. Now SQL doesn't really care about capitalization, but I typically capitalize SQL words like select and from, and don't capitalize data table words. But it's all up to you. It doesn't care. All right. To pull only patient 1, we're going to add a where clause. So it goes select the columns that you want from the table that you want, where, and then you give it a condition. So our condition is that patient ID equals 1. So when we run this, it's only going to give us, all rows where the patient ID is equal to 1, and it's going to give us these 3 columns like we asked for. Turns out patient number 1 has only been in twice. Well, who is patient ID 1 anyway? Let's pull the same data, all right, patient ID, admission date, and discharge date, where patient ID is 1, but let's also get the patient's first and last name. So how can we do that? Where is the patient's first and last name stored? Have we seen it already? Yeah, so it's stored in the patient's table. So what we need to do here is called a join. There are a few different kinds of joins, and we will talk about the differences in a minute. And this is the hardest SQL thing we're going to do in this entire boot camp, but it's still pretty easy. First, to make it easier, I want to give the admissions table an alias. An alias is just another name that we can use to refer to it, like variables in Python, all right? Aliases should have descriptive names. Let's use ADM. So to give the admissions table an alias, I'm going to add as ADM. And now, if I ever write ADM anywhere in this query, it's going to know that that refers to the admissions table. The next step is not strictly required, but it is tremendously helpful for the next person who's trying to read your SQL query. So we're going to add go through the rest of the query and explicitly say that each column comes from the admissions table. So we're going to add ADM dot in front of each of these. And all this is doing right now is telling the database and the next person who reads your query that all of these columns come out of the admissions table. None of this has changed the input at all. Watch, I'll run it. Nothing. It's exactly the same. But now we're going to join information from the second table. And we're going to use what is called an inner join, and I'll explain why in a minute. So after the from line, next line down, we're going to add a new line, right? That says inner join patients, that's the table we want to join to, as Pat. This as Pat here is another alias. Then on the next line down, I'm going to say on adm.patientid equals pat.patientid. So this tells it to merge the two tables together, right? But merge them so that for each row, when the patient ID equals, say, 1, we want to pull in that row from the patient's table. We haven't added any columns from the patient's table yet. So this is still going to return the same thing. But if we add pat.star, any guesses what this means? Hopefully you're saying this is going to pull all columns from the patient's table. All right? And then we can run it. And look, it pulled up the 3 columns we told it to pull from the admissions table, patient ID, admission date, and discharge date. And then these are all of the columns from the patient's table. Wow, it connected all of the patient information for patient number 1 to the admissions information for patient number 1. So let's see what happens if we just get rid of this where, that where clause. Well, now it connects all of the patient information to all of the admissions information. Notice how there are 2 patient ID columns, one from the admissions table and one from the patient's table. All right, so we still want to keep the admissions information, but the only info we actually want on the patients is their name and their birthday. So to do this, we need to change the pat.star. So in the select statement, we're going to change this to pat.firstname, right? pat.lastname, and pat.birthdate. Go ahead and run that. Yes, it returns only the columns we want. Excellent. Wait a minute. The admissions dates here are out of order. Wouldn't it be nice to see the incoming patients like chronologically? Well, to put the rows in order, we're going to use an order statement. So at the very end down here, we're going to add order by adm.admissionDate. So this is going to say, fetch me all of this data that we had before, but now we want to put it in order by admission date. Go ahead and run that. Yeah, there we go. Now all the admissions dates are in order. Nice. In the next part, we're going to work through a few scenarios and learn a few more commands. So in our first scenario, we want to see the trend in the number of patients that are admitted to the hospital every day. What do you think we might use to visualize a trend? Hopefully you're saying a line chart because that is the right answer. Generally speaking, to see a trend, you want to have dates on the x-axis. So for this trend chart, we want the date on the x-axis and the number of patients admitted on that date on the y-axis. And that's the information we need to pull out of the database to make the chart that we want to make. Remember, the chart we want to make is the trend in the number of patients that are admitted to the hospital every day. So we need 2 columns, admissions date and number of patients admitted. The admission date column already exists here in the admission table. So we'll start there. Let's look at the first few rows of the admissions table and see if we can find a way to count the patients on each day. So here we go. The query is select star from admissions limit 10. It would be better if the rows were ordered by date, right? So let's order them by admission date. For the limit always goes on the end. We're going to add order by admission date. Run that. Huh. Okay, let's look at 20 rows. These are all the same admission date, so let's look at a few more rows. Run that one. Yeah, okay. All right, so these guys were all admitted on like June 6, 2017. Let's count them. What did you get? 17? 18? Yeah, 17, I guess. All right, well, we could count the number of patients admitted on a date by just counting the number of rows on that date, right? So let's write a SQL query to count those rows for us. Starting with select, we know we want the admission date column, admissions date column. And we want to count the patient ID column from the admissions table. So let's run that and see what happens. Well, instead of counting the patient ID column by the admission date, it just counted the entire table, right? Whenever you use a function like count, you also want to use a group by statement. We want to group the rows by admission date and then count them. So we're going to count the patient IDs when they are grouped by the admission date. So at the end of our query down here, we're going to add group by admission date. Let's run that again. There we go. This is what we wanted. Now we've got a complete count of patient ID on each day, and all that's left is really a little cleanup. First, let's order the rows by admission date to put them all in order. Order by admission date. And then let's change the name here. This name, count patient ID. Let's give it an alias to make it a little easier to work with. This is just like what we did with the tables before. So we'll say as patients admitted. Rerun this. And there's our data. All right, we have here a column of admission date and a column of patients admitted. You can now download this data, put it in Python or in Excel, and whatever you want, and just make a great looking trend chart. For our next scenario, our boss wants to know which doctors have seen the most patients in a day, and they want to know which day it happened on. So let's start by figuring out what information our final table actually needs to have in it, okay? Which doctors have seen the most patients in a day and what day it happened on? Well, clearly we will need a row that, we will need a column that refers to doctors, and it needs to have a column with the count of patients seen, and it needs a column of admissions dates. So what table do you think we're going to use? Well, we need admissions date and patients, so it sounds like we're going to use the admissions table again. I mean, that's the only one with admissions dates in it, so let's start there. We'll start the same way we did for the last one with select star from admissions limit 10. Look at the table. It has a column that refers to doctors, attending doctor ID. We can use that to identify the doctors, right? And it has a column that refers to patients, patient ID. We can use that to count the number of patients that doctor has seen. And it has the admissions date. So we know that 3 columns we need. So let's write a query that only returns those 3 columns. So we're going to select here patient ID, admission date. Oh, you know what? We want attending doctor ID. Okay, so this is going to tell us the doctors. Then we'll need an admission date. It's going to tell us the admission date. And then we want a count of patient ID. Let's go ahead and run that. Well, what happened here? It is counting the whole table again. What did we leave out? We left out the group by statement. Well, what should we group by this time? We want to see the number of patients each doctor saw, so we want to group the rows by the attending doctor ID, right? So let's add that to the query, group by attending doctor ID. There you go. But what is this doing? This is counting all of the patients this doctor saw. It's not splitting it up by date. So we want to see the number of patients each doctor saw per day. So we need to group not only by attending doctor ID, but also by admission date. We're just going to add that to the end here, admission date, and run that. Yeah, this is the data we want. Each doctor has multiple days and a count of how many patients they saw on that day. But we want to see which doctors saw the most patients. So let's move those rows to the top using an order statement. Which column refers to the number of patients seen on a specific day? It's this one, right? Count of patient ID. Actually, let's give that an alias first, as patients seen. There we go. And then we'll order by patients seen. But SQL naturally, it gives the smallest numbers on the top. So to change it to put the large numbers on top, we're going to put it like this, descending. We're also going to order by admission date so that the admission dates are in chronological order. So like if there's a tie between doctors, it's going to give us the earlier admission date first. Let's run that, and there we go. It's now counting the patients correctly and ordering everything the way that we want. Okay, Dr. 16 and Dr. 9 both saw 5 patients, but Dr. 16 did it in September of 2018, and Dr. 9 did it in May of 2019. One last bit. So, attending doctor ID works for counting, but like the execs at the hospital aren't going to know which doctor is which by looking at their ID number, so let's put the doctor's names in there. Now, the doctor's names aren't in the admissions table, they're in the doctor's table. So we're going to need to join the two tables. First, let's give the admissions table an alias as ADM. And let's go through our query and let's add that to explicitly tell everybody that this is the table where all of these columns is coming from. Look, you often don't have to do this step, but I find it to be very helpful in remembering what exactly my queries are designed to do. All right. So we're going to do an inner join again. Oh no, this time we're going to do a right join, and we will, just a minute, discuss the difference, okay? So we're going to right join with the doctors table, and let's give it an alias as doc. Stop it. There we go. And we're going to do that on admissions table dot attending doctor ID is equal to the doctor's table doctor ID, like that. Now, what columns do we want from the doctor's table? Let's go down here and take a look. I'm going to do select star from doctors, limit 10. That's annoying. Sorry, in this one it doesn't let you do the, maybe it'll let me do it this way. There we go. All right. So in this one, the semicolon doesn't work. You have to highlight it if you want to just run a single piece. So this is the top 10 rows of our doctor's table. We have doctor ID, first name, last name, and specialty. So since we just want to identify the doctors, what columns do we want here? From the doctor's table, we want the first name and last name. How's that sound? But let's actually put these over here because it loads columns in order. So in our final table, it's going to tell us the attending doctor's ID, their first name, their last name, what date, and how many patients they saw on that date. Let's go ahead and run this. Sorry, you can't have this on front of patient seen because patient seen is an alias. There we go. Ah, perfect. So, Irene Brooks, Dr. Irene Brooks, saw 5 patients on, September 25th, 2018. Dr. John Nelson saw 5 patients on May 20th, 2019. Perfect. I mean, this is exactly what we want, right? Now, there are a few other ways to approach this scenario, but this one works, and often that makes it good enough. And since this is a one-off problem and we're dealing with small tables, we don't really care that much about efficiency. If we needed to run this often, or if the tables had like millions of rows, we might need to make changes to our query to speed things up. So a big part of any professional job is recognizing what matters and when. Before we sign off, let's talk a little bit about joins. There are 4 main types of joins. They are inner join, left join, right join, and an outer join. They are all about which rows matter. An inner join says that an observation has to appear in both tables to matter. So if we did an inner join here, inner join on the doctor's table, then that means a doctor ID has to exist in the admissions table and the doctor's table to exist in the output. So if doctor ID equals 16 didn't exist in both tables, this row would not be here. A left join says that a row only has to appear in the left table to matter. So in this query, if we did a left join, what did I do wrong? There we go. Left join,
if it exists in the admissions table, but not the doctor's table, would still exist. It would just be empty in all of the columns from the doctor's table. So let's say attending Dr. ID 16 was in the admissions table, but it wasn't in the doctor's table. Then with a left join, it would still be here, but these rows, we wouldn't have the name Irene Brooks. It would just be empty cells. But the row would still be there. Now, a right join says that an observation only has to appear in the right table to matter. So for this example, if we did right join, which is what we originally did, then if a doctor ID existed in the doctor's table but did not exist in the admissions table, then we would still get a row, but it would have a missing attending doctor ID. So like if, say, Dr. Irene Brooks didn't have a value in, like had never seen a patient, perhaps, then what we would get is the first name and last name columns would exist, but all the names from the admissions table, patient seen, admission date, and attending doctor ID would all be empty. And an outer join says that any observation in either table matters. So in this query, if we had done an outer join, whichever table didn't have doctor ID equals 16, that table's columns would just be empty. So if 16 existed in the admissions table but not the doctor table, then we would have attending doctor ID 16, admission date, and patient seen, but there would be no name. Whereas if doctor ID equals 16 existed in the doctor's table but not the admissions table, we would have a first and last name, but we wouldn't have an attending doctor ID, number of patients seen, or admission date. Surveys apparently say that left joins are the most common, but in my experience, I've used inner joins the most. And it really depends on how your data is set up and what you're trying to do with it. This website that we've been using, sql-practice.com, has a bunch of test questions available to help you practice SQL, and I highly recommend you spend some time regularly working on answering these practice questions. All right, you can just select one. It tells you what it wants you to do. Show the first name, last name, and gender of patients whose name is M. So this is my solution here. Select first name, last name, and gender from patients where gender is M. We're not going to be spending more time on SQL in our lessons, but it's a very important skill for any data professional, especially in your early career. And you need to know how to do it, and the best way to learn is to practice. At the risk of repeating myself, SQL is very important for data science, especially early career. It's also simple and intuitive, and it can be learned very quickly. Like when I started my first data science job, I could barely do the stuff that we did in this video, but just a few weeks later, I was much better. So make sure you get out and practice SQL. It is well worth it. Leave your questions in the comments. Scroll down and see if you can answer somebody else's questions. Now, if you learned anything from this video, please give it a like. And if you want to keep learning with me, go ahead and subscribe. Next week, we're going to start making predictions. We're going to look at graphs and do some math-free statistics, and we're going to figure out the best way to make predictions, and we're going to guess how accurate our predictions will be. The next video should pop up, and I'll see you there.